The Snider-Enfield, Ammunition, Part 2. In this second of 2 parts, we'll talk about the cartridge assembly, the charge, the filler, the wad, and seating the bullet. We'll then talk a little bit about how results affect how you load the cartridge. We'll talk about the importance of dedicating brass to individual rifles, and finally, how to package your ammunition. So here we are then. We've selected and cast our bullets. We've sorted and lubricated them. And our brass is now prime. We're now ready to assemble the cartridge. The first step of which is throwing the charge. Now this can be done all sorts of different ways. You can weigh individual charges, or you can use a simple handheld powder measure. I use a Lyman 55 powder measure. When you're doing a lot of shooting, and resultingly a lot of loading, it makes sense to have a bit of help when you're dispensing your powder. I might make a small interjection here about measuring powder. A grain is 1/7,000th of a pound, and therefore a measure of weight. And it's important to note that although volumetric measures, such as the handheld one, or indeed the Lyman 55, are marked with grain increments, these are a rough guide only, and true accuracy can only be attained by setting those measures so that they throw the correct weight of powder. What that weight of powder is for best shooting can only be arrived at through trial and error. The service charge of the Snider was 70 grains plus or minus 2 grains. But service charges are rarely the most accurate, and were only chosen historically so that the bullet would have enough power at long range. As far as maximum charge goes with the Snider, the rifle will handle upwards of 80 grains, but that is a heavy charge and is not very comfortable. Using the service charge as a bit of a benchmark, I've selected loads that are the most accurate. Here's an example of some workup. So here are 2 examples of grouping shot with 2 different loads. The one on the left here is shot with 75 grains of 2F. The one on the right, 62.5 of 3F. So once you have your load chosen, you can set and confirm your powder measure. Once that's done, you can go ahead and load all your cases. I usually check every 10th one for quality control. Once the cases are charged, always double check with a flashlight. With the Snider cartridge, a filler of some sort is critical. As mentioned in part 1, the service cartridge had a small amount of carded wool, which was placed on top of the powder before the bullet was seated. It took up what little space was left between the bullet and the powder. A problem to overcome when shooting the Snider with modern loads and components is dealing with the case capacity. Because of the balloon head construction of the shotgun brass and overall greater capacity than the old service cartridge, what might be termed a normal powder charge doesn't even come close to filling the case up to the base of the bullet. This leaves the question of what do we do with this empty space? Generally speaking, we don't want much of an airspace inside a black powder cartridge, although there are some to whom this is not an issue. Now some explanation here is required. We are shooting with a .600 bullet. This is for best accuracy. And this is also going to be loaded into a case that has been fire foamed, and therefore wider than a die-formed case. The dimensions of both the bullet and the case are such that there is next to no neck tension in the cartridge. Indeed, the bullet is held in the case with the tackiness of the lubricant in the lube grooves. This leaves us somewhat constrained with the type of filler we're going to use. Essentially, it has to be non-compressible. So, cotton, wool, or kapok are not suitable for fillers in this type of Snider cartridge. Enter the solid filler. I use plain old cornmeal, but other things such as semolina or cream of wheat are just as suitable. So there's a bit of trial and error here to find out the correct amount, but once that's done, this is placed right on top of the powder charge. On top of this, to keep everything together, I place a card wad, and then the bullet simply sits on top, unable to push down into the mouth of the case, and is held at the correct point in the casing for the overall length desired. For my purposes, that is to say for the load that I've chosen in the correct powder granulation, I found that a lead dipper of 2.8 cc's worth of cornmeal on top of the powder is the correct amount. As mentioned, I place it right on top of the powder, which is of course at the bottom of the casing. The cornmeal actually is of a similar granulation to, in this case, the 3F powder I'm using, so there's not a lot of mixing in the casing going on. Once the filler's been put into the casing, a quick tap to settle all the contents. It's now time for the card wad. I found that 20 gauge card wads seem to work for my purposes. They fit just snugly enough to hold everything together. That's their first function. The second function is to provide a barrier between the bullet and the filler so that nothing sticks to each other and the bullet flies true, unencumbered. I seat the wad on top of the filler with a dowel. It's important that I'm not compressing the load, I'm just making sure that everything's snugged up. The next step is to seat the bullet. Now this preliminary step here that I'm going to show you is something that I do personally. I just feel as though it makes the cartridge more consistent. Because of the method of lubrication I use, in that I dip the bullet into the lubricant, the bottom of the bullet is necessarily covered in that lubricant. I scrape it off, and that lessens the chance of anything sticking to the base of the bullet. Once that's done, the round is simply hand-seated into the casing. It's held at the correct height by the combination of powder, filler, and wad. For those of you familiar with reloading for smokeless ammunition, the fact that there's no neck tension on this cartridge may cause some alarm. Dozens and dozens of Snider shooters will agree with me when I say that this is simply not an issue. Sometimes in the cleaning process or just in the handling of these empty casings, the mouth of the casing can get dented or malformed. To remedy this, I use my Martini wad punch, which is tapered on the outside. Placed in the mouth of the case and rotated around a couple of times, this remedies any deformity. So we've got our powder, our filler, our wad, and the bullet, all seated to the correct depth without the use of a single die or press. The Snider really is one of the most simple black powder cartridges to reload for. Of course, the proof's in the pudding, isn't it? It's all about the results. Working up a rifle entails a lot of experimentation, and although I haven't perhaps exhausted every avenue, I have experimented with some things that simply didn't work. For instance, the use of a grease cookie, which I thought initially would be beneficial to the Snider cartridge, in fact was detrimental to accuracy. It either rode up the bore incorrectly or stuck to the bullet, and the groupings using those grease cookies were nowhere near acceptable. Once I switched to using the cornmeal filler and fine-tuning the powder load, the groupings ended up like this. This is a group shot before I modified the sights to zero it correctly. That said, we're looking at approximately a 5-inch group, shot at 100 yards. The patch is covering one flyer, but even with that flyer, a figure of merit of 1.58 is good in my books. If you discount that flyer, the figure of merit drops to 1.37. Once I modified the sights and brought the main point of impact down, the rifle was shooting dead on. The whole Snider reloading evolution needs to be tied together with this point. The procedures that I've shown in these two videos are predicated on one thing, that is, dedicating brass to a specific rifle. Due to the fact that there's no sizing of brass after you've fireformed it, if you're going to do a lot of shooting with multiple Sniders, the best option is to have a set of brass for each. Here's a demonstration. Using brass that's fireformed to my Mark III long rifle, you can see that it inserts into the breech with no problem. The rim is flush, and the breech closes properly. Now if I use that same case and try and place it in the breech of my Mark II 2-star short rifle, well, you can see, because of the small differences in tolerances within the breech from rifle to rifle, this particular casing will not fit. There are of course dies out there. Lee, for instance, makes a set. But if you use the sizing die, this squeezes the brass back down so that it will only accept the 5.75 bullet as described in part 1 of this series. Not only will you not be able to use the best performing bullet, but you will also be working your brass considerably, thus shortening its lifespan. Of course, what's the point of making historical ammunition if you're not going to package it historically? I am kidding, of course, but for those interested, here's how I do it. Snider cartridges were packaged in packets of 10 rounds, and looking at examples on the internet, it seems that some are packaged with the nose or the bullet end of the cartridge all facing the same way, because there's a distinct taper to the packet. Others are square-shaped, indicating that the bullets are laid back to front within the packet. They were packaged for transit about the globe in quarter barrels. I package my rounds so that they're alternating within the packet. To this end, you need a jig that measures 3 3/8 inches across. The height of the sidewalls doesn't really matter, as long as it's higher than 2 rounds stacked on top of each other. There are 2 pieces of paper used, the outer and the inner wrapper. They're made out of standard computer paper, so the long axis is 11 inches, with the short on the outer wrapper being 4.5 and that of the inner wrapper 2.25. Note the orientation of the label on the outer wrapper. Placing this label centered face down in the jig, you then crease the paper at the corners. This will form somewhat of a, let's call it a bed, to lay the cartridges in. Once that's done, the inner wrapper is placed inside the outer, with 1 cartridge placed on top. Subsequent cartridges are placed facing the opposite direction, with the inner wrapper weaving between them. Once the last round is in place, they'll all sit nice and square inside the jig. The next step is to simply fold the outer wrapper like you're wrapping a birthday present. I usually cheat and use a piece of tape to hold the initial fold together. We then carry on with the birthday present theme and fold the ends. This looks kind of awkward, but I'm trying to keep my hands out of the way so you can see what I'm doing. When doing it as far as production goes, it folds up in a couple of seconds. With both ends folded, you can then remove the packet from the jig and get ready to tie the string. I use some cotton twine that's about 18 inches in length. Just tie it up like an old airmail parcel. After trimming off the excess twine with a pair of scissors, in this case a very large pair of scissors, the packet is then ready to go. 10 rounds, Snider Marksman, for the use of. As explained in earlier videos, these packets were carried in the main pouch, they being emptied into the expense pouch when required.
And that, in a nutshell, is the way I make ammunition for the Snider rifle. It really is one of the most simple cartridges to reload for.
Robert, where's my food dehydrator?
Shit.
Remember, for your Snider brass or your Snider bullet needs, there's always Martin at X-Ring Services.
The wind's in the right direction. I get a nice space full of cornmeal.